Hi everyone. Today we're going to do quadratic formula part 2. Now what we did in quadratic formula part 1 is we learned the quadratic formula and we practiced some problems, but I picked out specific ones where the square root part always worked out perfectly and turned into just a number. But that doesn't always happen. So what I did is since then number 1, we did a lesson where I reviewed how to simplify radicals with you guys. And now we're ready for part 2, where we're going to take some quadratic formula questions, but that square root part isn't going to work out so perfectly. You're going to end up with a radical in your answer. Okay, so first let's remember, when we were solving equations by factoring them, sometimes we ran across equations that weren't factorable. Like we tried to find two numbers that multiplied together to give you this and add together to give you that, and it just didn't work out. So here's an example of one. If I asked you to factor this equation, you can't do it. Because what I'm asking you guys is to find two numbers that multiply together to 1 and add together to give you 5, and it just doesn't work. The only numbers that multiply to give you 1 are 1, 1, and 1, and 1 plus 1 is 2. So this one is not factorable, and we weren't able to solve it before. What that means is that you can't solve it by factoring, but it doesn't mean that you can't solve it, period, because you can solve it using the quadratic formula. And that's our next step. That's what we're really doing for part 2, is we're taking a look at those equations that before were not factorable and we couldn't solve, and we're still going to solve. So the best thing about quadratic formula is that it always works. With factoring, it sometimes works and sometimes doesn't. Maybe the equation's factorable, maybe it's not. But with quadratic formula, you don't even have to worry about that. It will always work. Now, if you come across an equation that isn't factorable, that's because the answer isn't a whole number or a fraction. It actually has a radical in it. It's what we call an irrational number. So what we're going to do, we're going to follow the exact same steps that we did in quadratic formula part 1, meaning we're going to make sure it's equal to 0, pick out our numbers a, b, and c, plug them in, start solving. But when you get to that radical part, it's not going to be the square root of 81, it's just 9. Or the square root of 25 is just 5. It's going to be a number that you have to simplify and leave in your answer, like we did in our last lesson when we practiced simplifying radicals. So let's go ahead and try one out. This is our example for today. It's x squared plus 6x plus 4 equals 0. And I said solve for x. Now notice in the directions I didn't say one way or the other. I didn't say solve by factoring. I didn't say solve by quadratic formula. But if you try to solve this one by factoring, you'll see that it doesn't work. There aren't two numbers. In fact, I'll go through the work real quick. If I'm trying to find two numbers that multiply together to 4 and add together to give me 6, my choices are 1 times 4, or negative 1 times negative 4, 2 times 2, or negative 2 times negative 2. And if you start adding, 1 plus 4 is 5, negative 1 plus 4 is negative 5, 2 plus 2 is 4, negative 2 plus negative 2 is negative 4. None of them add up to 6. So that means this one is not factorable. So we have to use quadratic formula for this one. So let's do that. So once I realize I want to use quadratic formula, I'm going to pick out a, b, and c. Now a is the number in front of x squared, which is 1. If you don't see a number, it's a 1. So for this question, a is going to be 1. B is going to be positive 6 for the plus 6x. And C is going to be positive 4 for the plus 4. Now the quadratic formula, I'm going to go ahead and just copy the whole thing down. We learned it in part 1. It's x equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. And then step 2 is let's just put all the numbers in. So first of all, let's start with that. What the formula says, it looks like negative b, but I told you in part 1, don't really say negative, say the opposite of b, because you always want to do the opposite. So in this case, b is a positive 6. I'm going to change the sign and start with a negative 6. Then we have plus or minus the square root of b squared, that would be 6 squared, minus 4 times a, which is 1, and also times c, which is 4. And then the bottom is 2 times a, which is 1. Okay, everything looks exactly like part 1 so far. What's different is this next step. So I'm going to leave the -6. On the bottom, I'll do the 2 times 1. 2 times 1 is 2. That's easy. Now, when I go to do this, in part 1, I said just type it into a calculator, you'll get your answer. And every single time we got a whole number. But this time you don't. So this time I'm going to do a little bit of work off to the side here. What you actually get, if I just do the part inside the square root, 6 squared is 36. 4 times 1 times 4 is 16. So I end up with 36 minus 16. What I end up with is, and I'll put it way up here in the top corner, I end up with the square root of 20. Now that's not a perfect square. The square root of 20 doesn't equal just some number. So what we do, our second choice, is to try and find a perfect square factor. So if I start thinking about my perfect squares, the first one I think of is 4. I go, okay, can I divide 20 by 4? Yeah, I can. So I'm going to break that up. 20 is 4 times 5. So I'm going to break this up into the square root of 4 times the square root of 5. And then remember, we said in the last lesson, you always, you take the one that was a perfect square and you simplify it. The square root of 4 is just the number 2. You take the one that was not a square root and you leave, or not a perfect square, and you leave it. So the square root of 20 simplifies to 2 radical 5. Now, in this case, once you have the radical in there, we're not going to do like we did last time and separate the plus or minus. There's no reason to, because you can't simplify if one of them has a radical. So I'm going to say for now, if you made it this far, I would count that. I mean, that can be simplified a little bit more, and I'll show you how in just a second. But if you made it that far and boxed this up, for where we are in class, I would give you full credit for that, 100%. I would say, great job, you found the answer. But let me show you one thing, just so you can kind of start thinking about this thing for the future. One way to simplify this is I say, maybe I can simplify like that over 2 part. Well, the way you would do that is take the top and split it up. The -6 plus or minus 2 square root of 5. And instead of one fraction, make 2 separate fractions. And put each one over that same denominator, 2. Then what you can do is simplify each of those fractions. So the first part of that is -6 over 2. That would just be -3. And then you get your plus or minus. Now, when you're simplifying the second part, don't touch the radical. Just leave that alone. What you want to do is see if you can simplify the number part right here. And you can. In fact, this time they cancel out. If you have a 2 on top and a 2 on bottom, you can cancel those. And you get just -3 plus or minus radical 5. That would be the best answer to the question. That's the simplified best answer. But remember what I said, because we're just learning this. This is our first time doing this. If you got to the one that I boxed up in green, that's perfect. I'll give you full credit for that. If you get to the one, the blue one, that's even better. I mean, that's really, really the best answer. But the idea is, remember, we're still doing quadratic formula. We're still taking that formula and plugging numbers in and simplifying. What's different is that work off to the side there over here, this part. Because starting today, they're not all going to be perfect numbers. It's not always going to be the square root of 49. And you go, okay, well, that just equals 7, and I have just a number. It's the square root of 20, and you have to simplify it and then finish your answer that way.